All right, so in our last explainer, we broke down how PHP handles all the input coming from the web. But once you've actually got that data, what's next? That's the big question, right? Well, today we're diving into two absolutely critical ideas for any web app: how you remember who your users are and how you protect their information.
Yeah, getting the data is really just the beginning. The moment you have user information, you're not just a developer anymore. You become a custodian of that data. It means your job isn't just about building cool features. You're now responsible for keeping track of people and defending their data from some very real threats.
Okay, so here's our game plan. First, we'll tackle the core problem of the web, HTTP's complete lack of memory, and see how PHP gets around it. Then, we'll get into the essential skills of validating input, fighting off the most common attacks, and finally, the big one: how to handle passwords and authentication securely.
So, the first thing you really need to get your head around is that HTTP, the protocol that runs the entire web, is fundamentally stateless. It has a terrible memory. In fact, it has no memory at all. Every single request your browser sends to a server is treated like it's the very first time. The server has no idea who you are or what you did just 1 second ago on the previous page.
And that's exactly where state management swoops in to save the day. It's how we literally give our applications a memory. It's what takes a bunch of disconnected requests and weaves them into one continuous conversation. You could even say that state management is what turns requests into relationships. And in PHP, we have two main tools for the job: cookies and sessions. The huge difference here is location, location, location. Cookies are just tiny bits of text stored right there in the user's browser. Sessions, on the other hand, store the important data safely on the server. The browser just holds onto a little key, a session ID, to prove who it is. And this separation is a really big deal, because it makes sessions perfect for sensitive stuff like login information, while cookies are great for less critical things like remembering if a user prefers dark mode.
Setting a cookie is pretty easy. You just use the setcookie function, give it a name, a value, and tell it when to expire. Now here's the one rule you have to remember. This function has to be called before a single character of HTML is sent. Why? Because cookies are part of the HTTP headers, which always come first. Now, for sessions, your first move is always to call sessions start. This one little function tells PHP to either find an existing session for that user or kick off a brand new one. After that, you get access to this kind of magic super global array, and you can just start reading from it and writing to it. PHP takes care of all the tricky server-side storage behind the scenes.
I love this way of thinking about it. It just clicks. A cookie is like your library card. It tells the librarian who you are when you walk in. The session, though, that's the librarian's computer screen, keeping track of which books you've checked out during this visit. So we know how to manage our users' data, but here's the twist. We also have to protect our application from that very same data. And this brings us to what is, without a doubt, our first and most critical line of defense: validating and sanitizing every single thing that comes into our system. This right here, this is the golden rule of web security. You have to work with a zero trust mindset. Assume everything, every bit of data from a form, from the URL, anything, is crafted by a malicious hacker until you have proven without a doubt that it is safe.
It's so important to understand that these are two different jobs. Validation asks, is the data the right shape? Does this actually look like an email address? Sanitization asks, is the data dangerous? It's the process of cleaning out or neutralizing anything harmful, like bits of code an attacker tried to sneak in. You absolutely have to do both.
Okay, with our data properly vetted, we can zoom out a little and start building our defenses against some specific, very common attacks. These are the classic vulnerabilities that every single web developer needs to know how to stop cold. First up, the big one: SQL injection. This is where an attacker cleverly slips database commands into a normal input field, like a search box. If you're not careful and you just stitch that input directly into your database query, that attacker can basically take over. They could read all your data, change it, or just delete everything. Luckily, the defense for this is both incredibly effective and honestly quite elegant. It's called prepared statements. The idea is simple. You send the database your SQL command first, but with placeholders instead of the actual user data. Then, as a completely separate step, you send the user's data. This way, the database knows the first part is a command to be executed, and the second part is just plain data to be used. It never confuses the two, and the attack is completely shut down. And this is the real takeaway here. This isn't just some abstract, technical best practice. It's a core responsibility. When you protect your database, you're really protecting the people who have trusted you with their personal information.
Next on the list is cross-site scripting, or XSS. This is a sneaky one. It's where an attacker manages to inject their own malicious code, usually JavaScript, into your website, which then gets run by all of your other innocent users. The defense is beautifully simple. Anytime you display content that a user provided, you must wrap it in HTML CHREPRASR. This function takes dangerous characters like angle brackets and turns them into harmless text, so the browser just displays them instead of executing them. And finally, we have cross-site request forgery, or CSRF. This is a tricky attack where a user who is logged into your site is tricked into clicking a link on another malicious site, which then secretly makes a request to your site on their behalf. We stop this with what's basically a secret handshake using anti-CSRF tokens. You generate a secret code, hide it in your form, and then when the form is submitted, you check to make sure the secret code matches. No match, no action.
And that brings us to our final, most crucial layer, authentication. This is all about verifying who your users are and guarding their most precious credential, their password. Let me be absolutely crystal clear on this. This is a rule you can never, ever break. Do not store user passwords in plain text, ever. Because if you do and your database gets breached, you've just handed the keys to every single one of your users' accounts to the bad guys. Instead, you store a hash, a one-way, irreversible scramble of the password. And the best part is, PHP makes doing the right thing incredibly easy. There are two functions you need to know. When a user creates an account, you use password hash to safely store their password. Then, when they log in, you use password verify to check if the password they just typed matches the hash you've stored. That's it. PHP handles all the complex and critical cryptographic work for you. It's also worth knowing about HTTP basic auth. Now, this isn't something you'd build a whole application on, but it's a super fast way to password protect a simple page or maybe a staging area. You just send one specific header, and the browser itself will pop up that familiar username and password box. It's a great tool to have in your back pocket. So as we wrap this up, I want you to think about security a little differently. It's not about being paranoid, trying to guess every crazy thing an attacker might do. It's about discipline. It's about building predictable, solid systems where data is always handled the same safe way every single time. And that really brings us to the most important takeaway of all. Security is not a feature you add on at the end. It's not a checkbox on a list. It is the foundation. It's the concrete slab you pour before you ever start putting up the walls of your application. So now that we know how to manage users and handle their data safely, it's time to connect to the thing that powers almost every dynamic website, the database. Go ahead and continue your journey with our next explainer, PHP working with databases. This is Developer Roadmaps. Map your path, build your career.